Welcome back, viewers on YouTube. In this video tutorial, we are going to prove the derivative of cosine function x. So first, let's state the derivative of cosine function. It says that if y is equal to f of x and it's equal to cosine x, then its derivative, the y dx, it's equals to negative sine x. So the purpose of this video is to investigate why this is true. I will be considering using the definition of derivative. So it says that if y is equal to f of x, then its derivative of that function, the y dx, will be equals to the limit as h approaches 0, where h is the delta x, of f of x plus h minus f of x, all divided by h. Perfect. Now, what will be f of x plus h? What f of x plus h means in essence is that if f of x is equal to sine x, then f of x plus h will be equals to cos x plus h. My bad, I wrote sine x, cos x to say, okay, cos x. So f of x plus h will be cos x plus h, cos x plus h. Perfect. Now, we can replace each of this value right in the definition of derivative, which simply means the definition of derivative will now be equals to the limit as h approaches 0 of f of x plus h, which is cos x plus h, then minus f of x, which is cos x, then everything entirely divided by what? H. Perfect. Now at this point, to simplify this, we need to revise one of the trigonometric identity, typically the compound angle. And this is the one we'll be considering using in this video. It says that the cosine of two different angles A plus B, typically their sum, is equal to the cosine of the first times cosine of the second minus the sine of the first times the sine of the second. So if that is the case, we can apply the identity to this. And therefore, we now have the y dx to now be equals to the limit as h approaches 0. So instead of cosine x plus h, we can simplify it as cosine x, cosine h, okay, according to that identity, the minus sine x, sine h, then the cosine x we have here, minus cosine x, then we still have the division of h. So everything is entirely divided by h. Perfect. Now, simplifying this forward, what I would do next is that I would like to combine these like terms. As you can see, cosine x, cos h, we have cosine x here. So we now have the limit as h approaches 0 of cosine x, cosine h, then minus cosine x, then we have minus sine x, sine h, minus sine x, sine h. Perfect. We still have the division of 0. Division of h, rather. So divided by h. Perfect. Now simplifying forward, we have this to be equals to, so instead I would like to factor out cosine h at this point. You can see cosine h is common right here. So we have the limit as h approaches 0 of cosine h as a common factor of cosine x. Left over is cosine h minus 1. Okay, now this is still there, minus sine x cos h. Then I'm still having division of h. Perfect. So at this point, I would like to distribute the h for, I just want to split the fraction, okay? Splitting the fraction, the denominator will be distributed for each of this term. Then we have the limit as h approaches 0. So instead I would put everything in a big bracket, okay? And we have cosine h, or cosine x. Why am I mentioning h? Then cosine h minus 1, then divided by h. Then we have the sign connecting them, minus sine x, sine h, all divided by h. Then I'm closing the big bracket. Perfect. Now at this point, since the difference of limit is equal to, since the limit of difference is equal to difference of limit, Then we can distribute this limit. And then we have the limit as h approaches 0 of cosine x multiplied by cosine h minus 1 all divided by h, the minus the limit as h approaches 0, all right, of sine x multiplied by sine h all divided by h. Perfect. Now, as you can see, the limit is such that h is approaching 0. And here we are having a function of x, cosine x. It definitely means it doesn't have business with the limit. So we can absolutely take it out of the limit. Same thing applies to sine x. So this is simply equals to cosine x multiplied by the limit as h approaches 0 of cosine h minus 1 all divided by h. The minus, taking sine x outside, we have sine x, the limit as h approaches 0 of sine h all divided by h. Now at this point, we need to consider the limit at which h is approaching 0 for small angles. So here it is. The limit at which x is approaching 0 for cosine x minus 1 all divided by x gives us 0. And this can be confirmed by using your calculator. Okay. Now, since x is approaching 0, it means x will be a very, very small number. So make sure your calculator is in radian. So if you plug in 0.0000 something as x, you subtract 1 from your result and divide it by what you plug in, you will observe that your result will be 0. And if you do the same thing for that of sine x, okay, at the end of the day, your result will be 1. And if you have a scientific calculator, you can just plug in, type in everything entirely, then you will realize that your result will be 0 and 1 respectively. So if that is the case, then this entire expression becomes 0, and we have cosine x multiplied by 0, and this also becomes 1. We have minus sine x multiplied by 1. And finally, we have 0 minus sine x. And at the end of the day, we have dy dx to be equals to negative sine x. And this is how the derivative of cosine x is equal to negative sine x. How to find this helpful? Thanks for watching. See you in the next video. Bye for now.